It's going to be all pretty much hands-on stuff. Um, we're gonna work through some electricity stuff together, and then when we're done with that, you'll have time to start talking about projects and stuff. Um, we have 8 weeks left in the class. I guess we're exactly halfway done, and so we're starting the robot project now, and really that's uh, the main thing we're going to do for the rest of the semester. Um, as far as the first project, can you show me hands? How many of you are ready to 3D print the thing? Okay. Well, anybody who's ready, will you please? I guess I'll put a note on D2L too, but send me those files. Let me show you one thing about that. How I need them sent. I need them sent as STL files for stereolithography. So to do that, let me get in here. And anybody, by the way, who's not ready to have your parts 3D printed, just, keep working on that. It works fine. It's not like there's not going to be any late penalty or anything like that. We can only print 3D print so many at a time anyways, but we need to get those done. There's going to be one more thing that you have to do on that first design project. And that is, if possible, and we can talk about it if it's not possible with your project, but I'm going to want to see a good, clear video of you using or trying to use your object for its intended purpose, And then I'm also going to want a document, and I'll give you details on it, but just basically telling me what you would do at this point to refine it on your next. We're not going to keep refining and refining, but I want you to think about it that way. Like the process is you do something, it's very unlikely that it's perfect the first time. And then from there, you think carefully about what you could improve to make it better, And so that's the last thing that you're going to do with the design project. And so I'm going to 3D print out your parts. You're going to get them back. You're going to do the videos. You're going to try them out. And then you're going to report to me what you would do differently. Or if you get it back and try it and you're like, this is perfect, and I already made $50 million on Amazon with it or whatever, then that's fine too. But most of you won't have that, I don't think. Okay, what am I doing? Fusion.
Are you asking for a percentage if you do okay?
I guess I'll ask. I don't really have much of a leg to stand on, but yeah. We're going to corner the doorstop market together.
Yeah, oh, true.
Okay, so I'm just going to open some random shape. Assembly, drawing, box drawing. Okay, so this is a thing. And so to save this as an STL file, Go to save as, I believe. That's right. Nope, that just saved it. Maybe export, yeah. Okay, so export. Scroll down. STL is one of the choices. These are the only file types they read in St. Louis. Not really. And so now that STL file is in your folder. Okay, so it should be centrifuge.stl. So there it is. That's the one that I just created. And now, if you click on that, double click on that. So the thing is, once you, at least if you're using the online Fusion, once you save it as export it to an STL file, it's still just in your online thing. So then you have to go to that file, double click on that file, and go to download. And now that's on my computer, and I can email it and stuff. Okay. All right. Any questions about sending me your part file or your assembly files? Okay, so now we're gonna get into Arduino. Did most of you manage to watch the videos? I guess I want to show a couple of. So I sent you some just examples that would be pretty involved, advanced projects, just to sort of get you excited about the possibilities. I mean, there's just unbelievable possibilities with even this sort of simple thing. But let me show you a couple videos of the kind of thing that that we're going to do in this class most likely. So we're getting going with Arduino. And so first of all, this is an old video. It just happens to be the 1 year that I took video of a bunch of these projects. Let's see, student work. Okay, so this is 2008, this class. And that's like that's right, it's a card shuffler, yeah. So it it is cool. So so the way it works, I mean, you kind of have to start little by little getting used to the way you have to think to make an Arduino thing, which is basically there's always some kind of sensor that's reading stuff. And then based on what that sensor reads, you're powering a motor, doing some kind of action. So like, for example, if you have a car that you want to avoid hitting stuff, it'll have sensors that are reading the distances to objects. And if it notices an object over here, then a motor makes it turn this way, And so you're constantly like looping through these actions, looking at the sensors, reading the sensors, and then making decisions based on what the sensors say to power something. So the way this works is there's an optical sensor in here that's just looking for whether it can see light, and as long as it can't see light, it means there's still cards in the hopper here. And so these motors are spinning, shooting the cards out there until they're all gone here, and then they're all here, and then it stops. So that's the card shuffler. And then I think when it stops, it dumps them back into the hopper, and then it sort of starts over again. One thing is you'll see with all these projects, uh, there's a lot of tape and kind of like wiggly stuff and whatever. I have been recently trying to put more emphasis on doing sort of simple tasks, but doing them well and making it reliable and not breakable, and thinking out the overall design a little bit more, you know. So yeah, and we'll talk about that as we go. But okay, so this is just a I think that truck is just on a remote control, and if you drive it up to that uh, drawbridge thing, the gate opens up to let it go through and then closes. Um, and probably again, these are the sensors that it's using are just optical sensors that are looking for each other across here. So if something breaks the connection between those optical sensors, like a garage door opener or something, if something breaks that, then it lifts these up. Oh, this guy over here, by the way, I think he's on a different project, but the guy in the dark shirt back here is a graduate of Twin Cities Engineering now. I mean, a long time ago, because this is 2008, but uh, he went on to go to Twin Cities Engineering. Okay, this thing is just avoiding an obstacle, you know. It scans. Oh, I guess it goes to it. But it scans the room for the thing and then turns to aim at it. This is that was a refrigerator with so if you pressed a button, it launches a pop can at you. It was a little scary to use. Oh, this is a card dealer. It deals blackjack or something. Everybody was using those Tinker Toy type things this year. It's funny that like
You have to like pre-shuffle the cards, or does it say?
I didn't have a shuffler, so those two could work together to. Yeah, exactly. So, anyways, those were projects we did in this class in 2008. Let me show you the ones, because this class is modeled after a class at the University of Minnesota in mechanical engineering. So let me see if I can find a video. I think it was from around like the early 2010s.
Actually,
Okay, so playlists. That one looks dangerous. Oh, 2021. I guess you can tell from the masks.
is this you?
The U, yeah. Making tea. So, anyways, there's just a lot of potential to do cool stuff. We're gonna do this in groups of basically like the people at your table, probably. I mean, and you're welcome to move around if you have someone you want to work with somewhere else. But groups of 2 to 4 people, kind of. Okay, so today, what I'm going to do is, so we're going to start with, we talked about simple circuit calculations. So today we're going to build some simple circuits. For this robotic stuff, there's really never any reason to do anything very complicated with the electronics. Any of the stuff that would require complicated electronics, we're going to do just digitally by programming these things. But we're going to start with building circuits, and we're going to do it using breadboards. And then we're going to measure things with multimeters. And then we're going to talk about using transistors as switches. Okay, so and using transistors as switches is going to be a big deal for these projects. And that's because, so I said that the idea of these Arduinos is you go through this rapid loop where your sensors do a reading and then you power some kind of action based on the reading of the sensor. And then you just keep looping through that over and over again really fast. And that could be the end of it, except that when you go to powering whatever device, motors a lot of times, lights or whatever, the problem is that these Arduino boards that we're using cannot provide very much current. And they can't provide enough current to power a motor for the most part, And so we need these boards to, yeah.
I remember you talked about this earlier. You talked about switches. Yeah, use the little amount of current and voltage to control switch.
That's right.
Controls a much larger amount.
Exactly. So instead, the board is just going to be like a gatekeeper and so we'll actually use, say, like a big battery to power the motor, and the transistor's only job is to decide when the circuit between the motor and the big battery is open and when it's closed, And so that's the principle of using a transistor as a switch. So hopefully we'll get to that by the end of today. Okay, so we're just going to make a circuit like this. It's about as simple as a circuit can be. We're going to go like a 9-volt battery to 1,000 ohm resistor. So this is 1,000. And this is 9 volts. Okay. And the way we're going to do it, the wiring, we're always going to use the breadboard. So the breadboard is this thing. Okay. The breadboard is this thing. And I said that so if you look at the A, B, C, D, E, and then the F through J, those rows are like connected. So if you put two wires into those, it's the same thing as sticking those two wires together. So let me show you how this circuit will look if you use a breadboard. So if this is your breadboard, and let's say these are the like one row of those holes A through E, we're going to have the 9-volt battery. We're going to go positive to one of these holes. Then we're going to go, so here's another row of A through E. And we're going to connect the two rows using the resistor. And the 1,000 ohm resistor would look like, so a blow up of this resistor would have brown, and then black, and then red. And there's also one in there that's brown, black, orange. That would be 10,000 ohms. So be sure that that's red and not orange. And then to finish this circuit on the breadboard, we're just going to go from that second row to the negative. Okay. You don't have to put this together yet. We'll do it in a second. But so the way this goes is positive current goes through the wire to this side of the resistor, goes through the resistor, and then out of that side of the resistor back to the negative. And once you connect this, current is flowing through there. Okay. Also, so you basically just have to take my word for it at this point. Like if you make that, like there's no way to tell that any current is flowing or whatever. So we want to use multimeters to measure and make sure that things are doing what we want. So one person from each table, can you come grab a multimeter from here? Just get one of these. And I guess we're also going to need, you can grab one red and one black. Let's just get these guys. One black and one red of those. So remember that a 1,000 ohm resistor is never exactly 1,000 ohms. And similarly, a 9-volt battery isn't exactly 9 volts. So we're going to measure those. Okay, so before we measure the current, so everybody use the values that you measured, and here's what mine is going to be like: a battery that's 9.18 volts, connected to a resistor that's 986 ohms. This is the positive side. This is the negative side. We don't care too much about the directions for what we're doing here. But so now we want to use Ohm's law to calculate the current through that resistor in this circuit. So Ohm's law says V equals the current times the resistance. So we have 9.18 is equal to 986 I. And so the current for mine, yours are all going to be a little different. But mine says 0.00931 amps or 9.31 milliamps.